Hello to everyone attending both in person and virtually. Today we will be talking about MAP or Models of Applied Privacy or how to do privacy threat modeling for an application using a persona based approach. My name is Jayati and everyone has had a long day. I'm a privacy engineer and this work was done in collaboration with my colleagues at the CCS research group at Comcast. So privacy can mean different things to different people, but generally when we talk about privacy, we mean protecting people's data and in turn protecting people themselves from unintended consequences of data. However, privacy can be breached in completely unexpected ways. For example, in the Strava breach that happened a couple of years ago, the route logs from Strava users gave away location of military bases. Hence, it becomes hard to find what problem a data action might cause, even when an application works exactly how it is supposed to. But why do we need to care about privacy? So, the first thing that comes to mind is compliance with legislative and corporate policies. There are also a couple of other advantages as well. So, products that are privacy preserving improve consumer trust, they improve product reputation, and often lead to better product quality. These are some of the benefits of having privacy controls built into the application by design. And this is what incentivizes integrating privacy into applications. The earlier we make products privacy preserving, the lesser we have to worry about kind of going back and patching threats that can harm people and their data. So suppose you're a product developer. You know how your application works and you know what kinds of assets and data are part of your application. But then how do you find unexpected privacy threats and protect your application from potential lawsuits? In order to find if there are privacy threats from the application to stakeholders, you typically would undergo a privacy threat model. In these sessions, you would share the architecture diagram with the threat modeling architect, and they would provide guidance on how to mitigate some of these threats in case they find them. And in order to find if there are privacy threats from the application to stakeholders, there are a couple of different steps that architects typically follow. So broadly, in threat modeling session, you would find some of the possible threats to your application and to users. You would then work to manage and mitigate those threats. And sometimes the threat modeling team or a different team would have a way to verify if the mitigations that have been recommended are integrated into your application. However, there are a couple of roadblocks. Typically, threat modeling is done by an assigned team of privacy experts. By the time an application gets to that stage, majority of the development is usually complete, making it harder to mitigate threats. Furthermore, these sessions are resource intensive, they need time and specialists, which make privacy by design costly. Additionally, threat modeling is often an art, with different modelers choosing different ways to represent threats. Inherently, this requires a degree of privacy expertise. So, what do we do? So, we need a framework for us to shift privacy left and to help developers find and understand privacy threats to their application. This would make the process visible much earlier in the software development cycle. Furthermore, it would supplement threat modeling by reducing the overhead for threat modelers who might be handling several different applications at the same time. Having a framework with common language that is consistent across applications helps not only with better threat metrics, but also increases organizational knowledge of these threats. So if you have multiple applications, you can find out what threat is the most common among all of these applications. Furthermore, it provides developers enough expertise to search for some of the threats themselves. So instead of reinventing the wheel, what we did is use some of the existing frameworks as a starting point to add a few more components that would help quantify privacy threats. To this effect, we build on existing frameworks like Linden, NIST privacy risk assessment methodology, taxonomy of privacy hunts, among other sources to create a holistic framework that can complement the manual threat modeling process. We use personas based on our threat actors from MAP who are doing problematic actions that result in a specific privacy harm or a range of privacy harms. The combination of these three elements cause a privacy incident, which gets recorded as a privacy finding in a threat modeling session. For example, to understand what were some of the previous works we were looking at to find privacy threat mechanisms, which are one of the components of MAP, here we see a list of existing privacy frameworks. We went through the complete list of threats and made note of any overlaps. There was a session earlier in Day of Security on Linden. I highly recommend checking it out if you have missed it. So the structure of the framework, which we discuss in a bit, gives enough information to a developer to understand not only who can cause a threat, but also what the threat is and what effect it can have. It contains three components: the threat actor, which we derive from CSAM's threat actor list and classify; threat mechanism, which we derive from Linden and PRAM; and threat impact, which we derive from taxonomy of harms and then classify. So let's start with threat mechanism. Threat mechanism defines the different possible paths in which threats can occur. For example, if the information flowing through an application can be used to identify a person, it is an identifiability problem. MAP currently lists 10 such mechanisms, and you will see a lot of overlap from Linden. The second component are actors who can cause a threat. As you can see, we have categorized actors based on whether they are present inside or outside an organization, thus changing what they can access. For example, an employee would have a lot more access into an application than a nation state actor would. The other categorization is based on whether they intend to cause harm to an organization or to a person. These result in 4 subcategories, which are further divided by expertise. Therefore, an outside neutral expert actor would be a researcher, for example. The third and final component is threat mechanism, the harm a privacy threat can cause. We divide harm into 2 categories, organizational or individual. We further divide these harms as explicit or implicit based on whether they can be measured or not. Explicit harm would be those that can be quantified, and implicit would be where we cannot quantify such harms. Combining the three, we get an overall privacy threat modeling framework. To know more about each category, you can visit the GitHub repository link given at the end of the presentation. So this approach gives us a standardized way to think about privacy threats holistically and help us rank them. Even more, it helps developers find privacy threats on their own. It is flexible, so you can add or delete categories as required. For example, if it is an internal application which does not deal with outside actors, so it can be scaled based on that. It's scalable, it's customizable depending on which industry the application comes under, and it moves away from an attacker-only approach. As you can see in the framework itself, we look at inside or like neutral actors who do not necessarily have a malicious intent. So MAP can be used in 2 ways. First, by threat modelers to classify their existing list of threats, and second, by developers to find threats using personas. This complements the privacy threat modeling process by guiding developers. And let's look at the first one, classifying and risk ranking threats. So we asked if we can show a use case of real-world incidents as personas using MAP. From a sample of 207 incidents from the Verizon Community Database, or VCDB, 183 incidents, which was like 88.4%, matched the framework categories. 24 did not match. Among these 24, 17 breaches did not have enough information about the threat actor or mechanism. So we can see that over like 88% could be classified based on this framework. The remaining 7 incidents that could not be categorized was either due to an error, which you can include as a threat, but we did not do that. Um, of course, as our threat landscape expands, we can keep adding more threats to the framework, and the flexible nature of MAP allows it. So among the 183 incidents that we classified, here is a breakdown by actor, mechanism, and impact. The highlighted number shows categories that sum up to over 80% of the incidents. It is interesting to see that employees and related entities, both present within an organization and both who do not have malicious intent, account for over 80% of privacy incidents. The top three mechanisms of privacy threats are non-compliance, disclosure of information, and identifiability. Finally, for impact, threats disproportionately impact individuals more, as we can see, over organizations, causing loss of autonomy, economic loss, and psychological harm. Reputational harm to organizations caused by privacy incidents also form a large part of the harms. Now we look at how developers can find threats using personas. We operationalize the framework using personas, and personas are not new. They are extensively used in product development to improve the user experience. What we do for MAP is we repurpose these fictional characters to not say that they're users, but to say that they are threat actors who can use an application to create different threat workflows. These could either be like malicious threat actors, but they could also be benign threat actors who do not intend to cause a harm, but inadvertently cause harm. For example, okay, can come to that in the next one. Yeah. So consider this example persona based on the Strava breach that happened a couple of years ago. So let's consider the actor to be a researcher named Orange, who is present outside the organization and is a security expert. I tend to move away from classifying threat actors based on gender because we don't want to do that. Orange. Okay, yeah. So Orange finds that route data from users are available publicly, and their concentration can reveal the location of military bases. This unanticipated revelation can cause reputational harm to an organization. Of course, this is one of the types of harm that can happen, and notice that we are more focused on what the persona does than who the persona is. Now it is up to the developer to determine whether this is a persona that will apply to their system. So if it is an application which deals with location data, is it publicly available? Would such a persona be applicable for their system? Another example could be Pineapple here, who is a college sophomore who uses a tracker to find physical objects. So they use this tracker to track a person's car and find their location. And this can lead to a physical harm to an individual in case Pineapple here decides to visit the location of this individual and break and enter into their car. So the application of these personas is very simple. Note that a security threat model is always the first step before you would go into a privacy threat model, because it often helps get a good sense of what the architecture diagram is. So the first step would be developers would review the application. They would probably get a little bit more familiar with MAP and the different threat actors and threat categories, and then select some of the subcategories that they think are relevant. They then pick one choice from each of the three major categories and create a combination. So for example, they could take one actor, one mechanism, say identifiability, and one impact, and try to create a persona. If this persona applies, it becomes a potential finding for mitigation. So developers can choose to discuss their findings and mitigation strategies with threat modelers, helping them as well. The privacy threat model then becomes a collaborative effort between threat modelers and developers who work together to find privacy threats early in their application and mitigate them before it goes into like a full threat modeling session. So with that, we wrap up our session. So to sum up, we present a unified framework for conducting threat modeling in organization that leverages existing frameworks and personas. This helps us classify privacy findings for applications. Our open source project is available on GitHub, and any additional research by our team can be found at the link given here. So, and always please feel free to reach out to us on LinkedIn, and I am happy to take any questions.